Hello everyone, welcome to Learn DAX channel. My name is Siddesh and in this video we are going to study two important concepts in DAX, which is the row context and the filter context. So in order to explain these concepts, I have set certain agenda for this video. So initially what we're going to do is understand filter context through two different cases with the total runs code measure. When I say total runs code, yes, we are going to have a cricket data set. We are going to have two different columns, which is the batsman name and country to understand the filter context. And to dig deeper into it, or maybe to have a bit even a further understanding of the filter context, I have also considered another sales table in which we are going to create the total sales amount measure, and then category wise and product name wise, we are going to see how the filter context is affecting the total sales amount measure. Now, in order to understand the row context, I'm going to do it slightly differently. So we have like five things on our agenda in order to understand row context. So first of all, I'm going to open an Excel sheet and I'm going to show you some simple Excel formula. Then we're going to play a little game, which is find the red ball. Then we go back to creating a calculated column in the sales table. Then we create the total sales amount measure, which we already have created in the filter context. We're going to use that. And then we are going to create a max price measure. So without further ado, let's get started with the video. So as you can see, we have two tables or two data sets over here. One is the batsman data set and another is the product and sales data set. So in the batsman data set, we have different batsmen like Virat Kohli, Steve Smith, Joe Root, Kane Williamson, and Rohit Sharma. And accordingly, we have batsman stats like the total number of matches that they have played, the total number of runs that they have scored, the centuries and the 50s, etc. So we have relevant information for these batsmen. And then we have the products table, which has the product names, the product categories, and the sale ID, the sale when the corresponding sale ID, the sale when it happened, the quantity in which it was sold, the price at which it was sold, etc., etc. So let's start with the agenda, which is to understand the filter context using the cricket data set, using the total sales amount measure, total runs code measure. I beg your pardon. So I will first create a new measure by until this point of the video, I have not mentioned what a filter context is. It's just we're just creating a measure, and I'll call it total runs scored. So the total runs scored should be the sum of runs scored by the batsman. Okay, now I will take this and pull it here. I will create a card visual. I will just set the display unit to none, and I'll just change the format of this. Okay, so now we have the total runs scored measure as 44188. Now, if you want to verify, it's very simple. We have this particular table in which there is a total row at the bottom, which is pointing to us that the total runs that every batsman has scored is 44188. So far we have tallied that the total runs scored measure is giving us the right output. And as in itself, without no context, we are getting no information about what this number actually signifies. What is 44188? I don't know. I mean, we know it that it is the total run scored. What I'm trying to imply here is without any context, this number has no significance as such. But let us try to pull the first part of the agenda was the batsman name. Now, if I pull the batsman name here and I'll just change the context here, not the context, the format actually. Yeah, now the font size is a little bigger and it's slightly better. So see, this number is 44188 and there are no transformations that have happened externally. And we have at no point in the measure mentioned that when I pull this measure onto any table that it has to modify itself according to the table that we are putting it in. What do I mean by that? What I'm saying is I have not mentioned in this measure. It's simply sum x, the table name, and the expression. At no point have I mentioned that when I pull this measure onto a different table with a different context, that it has to modify itself and give me an output which suits that particular context. I've mentioned it nowhere. But see what happens if I pull it here onto this table, and suddenly this measure is now adapting itself to the context, which is the batsman name. So as per the batsman name, we are getting the runs. So Joe Root has scored 8,249 runs out of those 44,188 runs. And it's very easy to verify because the Joe Root, I think, has the batsman ID 4. And if I check the batsman ID 4 here, we get 8,249 as the number of runs scored. So this is the filter context. The filter context is nothing but, let's say I have created this measure, and that measure, when I pull it out in any context, like in this context is the batsman name, then the way it is going to filter that particular measure, or the way it is going to distribute that piece of that whole pie into that context, that is the filter context. Now, this is one condition. Let's see if the measure modifies itself into another context. Should I pull out the country name instead of the player name? So let me pull out the country name in this case. So I drag country here onto the table. I convert it into a table. I change the format. So now what should happen as per the filter context is the number 44188 has to reshape itself in such a way that that pie gets divided in such a way that it represents the number of runs scored by the player of each nationality. So, like Steve Smith belongs to Australia, Rohit Sharma and Virat Kohli belong to India. So, when I see the runs scored against the India row, it should be the sum total of runs scored by Rohit Sharma and Virat Kohli. So, let me do that and we'll see if we can verify that with the numbers. So I will pull the filter, I will pull the measure over here. And one thing that we have already verified is that the total number of runs scored is 44,188. So that's tallied. Now let's see if the number of runs scored by Rohit Sharma and Virat Kohli as a sum is adding up to the runs that appear in front of the row India. So the runs scored by Virat Kohli in this case is, let me pull out the calculator real quick. So it is, first of all, 12,169, and the runs scored by Rohit Sharma stat ID 5 or batsman ID 5 is 9,115, which comes out to be 21,284, and it is 21,284. So yeah, we're good. The filter context is working. This is the filter context. So in terms of seeing the filter context work with the cricket data, we have done that. Now let's move to the second part of the agenda, which is to understand filter context again through two different cases with the total sales amount measure. Now this time what we're going to do is, let's say I just create a copy of the same and I will create a new measure. I think I accidentally hit the new column instead of measure. I'll just delete it real quick and then I'll create another measure. I will call it total sales amount is equal to sum x sales table, and then it will be the product of quantity into price. And I will just replace this field with the total sales amount field. So the total sales amount in this case for the sales table is 21,880. Now, just like we did with the case of batsman name and the country, I'm going to slice this data based on the category and the product name. And we want to see if the measure is going to adapt itself to those two particular contexts and what exactly it means. It is the filter context. So I will quickly grab the category here, change the formatting so that it's uniform with the other tables that we have currently on the on this canvas, and I'll pull out total sales amount. So electronics have a total sales amount of 18,350 and furniture have a total sales amount of 3,530. So like I've repeated in this video that the measure 21880 is molding itself in order to serve this context in which it is being called by the user, which is the category context, and then it is giving us the value. Now we will just take another example, which is the product name. And based on the product name, how the measure is going to reshape itself, we're just going to see that. So I'll pull out the product name. I will again change the formatting like I've always been doing throughout. And then I will pull the total sales amount here. And the same story. The number adds up to 21,880, just like it is here and here. The only thing that's happening is outside of the measure, the filter context provided by the product name column in each row is giving us the split of how much of the 21,880 amount is being used up. So that's filter context for you through 4 different cases. Now let's move on to the next topic, which is the row context. Like I said, first of all, I'm going to show you an Excel formula. Now, why I'm going to show that Excel formula? We are going to build up to the concept of row context. So let me pull this Excel sheet real quick. So I will first clear this field. If I want to find the sales amount for this particular table, it is going to be fairly simple. I just have to multiply price by the quantity. Then again, if I want to repeat that for the second row, I will say price into quantity. If I want to do it for the third row, I am again going to say price into quantity. So let me just write here in this cell is equal to price into quantity. Okay, it works. 10 into 2 is 20. If I do it again, is equal to price into quantity. Yeah, it works. 20 times 2 is 40. If I drag this along right to the bottom, I am getting the correct output, which is 10 times 2 is 20, 20 times 2 is 40, and so on and so on and so forth. So what's happening here is I am basically calculating the sales amount by iterating the row, iterating the table one row at a time. That's what's happening here. The key word here is iterating, and the other keyword here is row by row. So let's move on to the next part of the video, which is to find the red ball. It's a very simple game. I've created this little image in PowerPoint, and the task that we have is to find the red ball. So how are we going to do? It's simple. First, we're going to go see first ball, is it a red ball? No. Second ball, is it a red ball? No. Third ball, is it a red ball? Yes. And then we're going to stop our iterations. That's what we are doing. We are iterating. We are going one ball after the other after the other. And this is a very important thing to note when we are going to study the row context. So done with the first two parts of the video, let's try to understand how these dots are connecting in order to get to why we did these two exercises, which is the Excel sheet and find the red ball. Now I'll go to this sales table and I want to do one thing, which is just like I did in the Excel sheet, which is I took price and multiplied by quantity. Then again, I went to the second row, price multiplied by quantity. So I was doing it manually row by row. What if I want to do that in Power BI in a calculated column? What I will do is I will write sales amount is equal to price into quantity. Now see the difference. In case of Excel, I was doing it row by row. I was iterating it manually. But in this case, I just wrote the formula at the top. Power BI figured out that I want to go row by row. It took the first row, The price for the first row, the quantity for the first row gave me the value. So 800 times 2 is 600, 1600. 500 times 3 is 1500. 150 times 1 is 150. So it was able to auto detect that I have to iterate row by row in order to give the user the sales amount for this particular table. Now, can I do the same thing using a measure? Yes and no. Why no? I'll tell you. If I have to create a measure which says total sales amount measure is equal to sales price into sales quantity. Let's see what happens. I'm sure there's going to be an error. There was already a red underline. So it says a single value for the column price in the table sales cannot be determined. So what Power BI is trying to tell us is, I don't know how to start going through the table. I don't know how to iterate row by row over the table. So it's clueless. Like it knows what table it wants to fetch the values from, but it doesn't know where to start and how to iterate. And in order to do that, what we do is we use something called as an iterator function. So what an iterator function does is it is going to give the measure a context in which it can have a starting point. Okay, take this first row for this table, get the value, then move on to the second row, then calculate the value, then go to the third row, then calculate the value, and so on and so forth until you reach to the end of the table. So that is a row context. And how do we achieve that? Like I said, we use an iterator function. In this case, what we're going to use is a sumx function. So the sumx function, the first argument is the sales table. The second argument is going to be our quantity and price. Sales quantity into sales price. So it is the same as the total sales amount measure. There's nothing difference. See, the formula is the same. Sum x sales, sales quantity into sales price. I just repeated this because I wanted to show why simply multiplying price into quantity, which worked in case of a calculated column, did not work in case of a measure. So far we have covered that what exactly row context is, what exactly filter context is. Now let's conclude this video by creating a max price measure, and I want to see like what exactly this translates into when we are trying to find the max value. So let's say I have this table and I want to find among this particular column, which is the price column, which sale happened at the max price. So it's going to be fairly simple. I'll just say, okay, a new column. And because a calculated column inherently knows how to iterate, where to start and where to stop, it's going to be as simple as max price is equal to max price sales price. If I do that, it is going to pull out 1800 as the max price. Whereas if I try to replicate the same thing in a measure, let's see what happens. I call up a new measure. I will say max price is equal to, again, I'm going to use an iterator function. An iterator function is going to show, or it is going to instruct the measure to go to the table, to have a start point, to have a finish line, and to go row by row and try to understand which value is going to be the maximum value. So I will write max x, go to the sales table, and then check for the sales price. And now if I do that, and if I again drag it here, I convert it into a card, I change its formatting, we have the max price created through the measure as 1800, just like we got in case of the calculated column. So that is row context. It is actually a very simple concept wherein what we are doing here is the calculated column inherently knows by itself where to start, where to stop, how to iterate, what it's supposed to look for, and it does everything behind the scenes. Whereas for a measure, we have to explicitly define that, hey, this is the start point, this is the particular row, or this is the particular column, and you have to iterate it one at a time. And then once you find whatever the value you want, you just give that to me. So that's row context. And what I explained in prior to this is the filter context, wherein you have a measure and in no context it is just a pure number, but the moment you attach that number in some context like a batsman name or the country, it is going to adapt itself or it is going to modify itself so that the user can see the value in a different form. So that's all that I wanted to explain from this video of row context and filter context. I hope your understanding of the two concepts, even if improved slightly, that I will be very happy to know. And if you found any value from this video, please share it with your friends. And if you felt that at some point of this video that you would want to give me a feedback in terms of, hey, your interpretation of this particular topic or this particular concept is something that needs further improvement, then please let me know. I'll be very happy to go back and learn more about it, study more about it, and improve myself further. And like I say at the end of the video, happy learning and thanks for watching.